Welcome to Pomodoro Joe for Tuesday, June 27th, 2023. Today we're looking at LeetCode problem 373. Find k pairs with smallest sums. This is a medium problem. You were given two integer arrays, nums1 and nums2, sorted in ascending order, and an integer k. Define a pair u and v, which consists of one element from the first array and one element from the second array. Return the k pairs, uv1, uv2, etc., with the smallest sums. All right. And then we have some examples, and that's about it. All right, I am running super low on time. I only have about 20 minutes before the deadline of this problem, so we're gonna have to go through this really fast. We'll put 25 minutes on the Pomodoro timer, and we will get started. So for this, I will go through the brute force way first, just hoping, crossing our fingers that it will pass, because that is the simple way to do this. When it doesn't pass, then we'll do this the right way. Okay, so the brute force way to do this is just go through all of the different possible pairs, then sort them, and then choose the first k. So let's try that. All right, so let's see, we'll have some result. Guess we don't need this result, but I'll do that. Okay, let's see, then for every I in range, actually we don't even need the index. We can just have n1 in nums1, and then for every n2 in nums2. So now this is every single possible pairing of nums from nums1 and nums2. Now let's see, we need pairs, and we need to sort these pairs by their sum. So let's just do this. Let's have result will append this pair. So that's n1 and n2. So that's n1 and n2. So now we're appending all the different pairs into our result. Now we'll sort these, so result.sort, and now we need to pass in the sorting key, because otherwise this would sort by n1 and then n2, but we can give it a different key. So our sort key will be lambda, which is a function of x. So let's see, lambda, lambda x. Now our x is every element, and you can see our element has two numbers in it, so that will just be the sum of our element x. So we're sorting by the sum of these two values, and then we just return up to k, so the first k elements. Let's try this. All right, so that seems to work. Let's see if we can pass all the tests. Memory limit exceeded. We only beat 25 out of 35 test cases, so we run out of memory. So it's not a time limit constraint, it's a memory limit constraint. So that kind of indicates to me that we don't actually need all of the different pairings. All right, so this didn't quite work. Is there a way that we can just do a subset of these pairings? And there is. Unfortunately, it's going to take us a lot more time to code that one up. So we basically want the k minimum pairings, or the k values with the minimum sums. The problem with this approach is we're choosing the smallest number from nums1 and then going through every single number in nums2, including the largest number in nums2. So that means that before we add the second smallest number of nums1 to the smallest number in nums2, we're actually adding the smallest number of n1 to the largest number in nums2, which is probably going to be bigger than second smallest nums1 to smallest nums2. So this isn't the most efficient way of doing it. We're going through all the numbers nums2 before we even get to the second smallest number in nums1. So let's redo this whole thing, but now we'll use a heap. Now, why do I choose a heap? Well, a heap will give us the minimal amount. This is a min heap, so it will give us the minimum number of the current set of pairs. So we'll be adding new pairs to our set of pairs as we go, and we'll choose the smallest sum, basically that will percolate to the top of our heap. So we can just pop the smallest current pair in our heap from the top of our heap, add it to our result. Then we can add some more of these values to our heap. And we'll be adding our values instead of choosing just one number from n1 and then all the numbers from nums2. We'll add the smallest number from the nums1 and the smallest number from nums2, then the second smallest number from nums1 and the second smallest number from nums2. So we'll be building up slowly instead of just doing all the numbers from nums2, including the maximum numbers. So this will help us keep things small. All right, okay. So we'll need a heap. Now this heap will be a heap of different pairs. And what else do we need for this? Well, we'll need to keep track of a couple things, like how many values we've chosen so far. So I'll have that at 0. And we'll need to keep track of, well, to make this easier on ourselves, I'll keep track of the maximum index of each array here. Let's see, I'll need these to be nums1 and nums2. Okay, and our heap, we'll start out with some value. Now, one thing with our heap, what are we going to store in the heap? We could just store the nums1 and nums2 pairing, but if we do that, we'll have to sum them to figure out how we sort the heap. Now this heap will be sorted by the first element first, so we kind of want the first element of our element in the heap to be the sum. So I'll put a note here. Heap values are going to be a tuple of the sum of the elements, and then n1 and n2. So that's going to be our data structure inside this heap. That way we can sort the heap by the sum and get the smallest sums first, and have these pairs still associated with that sum. All right, so our first one we can actually add if we wanted to, but we can have nums at index 0, nums1 index 0, plus nums2 at index 0. And then we'll have to have the nums1 and nums2. So that's nums1 index 0, and nums2 index 0. Maybe I'll do this out here. Maybe I'll have first pair. I'll just make this a little easier on ourselves. So our first pair will be this. nums1 index 0, nums2 index 0. And so I'll make sure that I put the first pair in our heap. It's a tuple wrapped in a tuple. And then instead of doing this plus, I can just do sum of first pair. Okay, so this gives us our first element in our heap. All right, now it's just a matter of going through the heap, grabbing the smallest elements off the top each time and adding those to our result. So while we have a count that's less than k, we'll pop our element off the heap. So what do we do? This, what should we call this? Pair or element? I guess I'll just call this pair. Or I guess it's a couple things. It's the value plus the pair. So that's going to be our index 1 and index 2. Oh, right. I don't actually want the numbers here. I want the indices here. That's actually going to throw things off a little bit. So let's back up. Because I'll be changing my indices, I'm not changing the values, I'm changing the indices each time, because I'll choose the first index from nums1, the first index from nums2, then I'll choose the second index from nums1 and the second index from nums2. So I need the index. Okay, so let's change this. So this is 0, 0. And that means I can't do this sum here. I do have to do nums1, index 0, plus nums2 at index 0. Okay, and we'll just do a heap q, heap pop to pop this off the heap. If you don't know about heaps, I have another video you can check out, but the heaps will basically keep track of the smallest valued element at the top of the heap. So heap pop will give us the value plus the indices where we found that value. Next, we need to add this result, or this pair, to our result. And I do need to wrap this. It looks like we need to have these in lists, so I have to make a list out of index 1 and index 2. And then we'll make sure that we record that we added that result. Okay, what are our options after this? We've added this to our result. Now we can move our indices. We can either move index 1 up to index 1 plus 1, or we can move index 2 up to index 2 plus 1. But we have to make sure that we don't overflow our bounds here. All right, wow, this gets complicated. So let's have a new index 1. That's just index 1 plus 1. Now we check. Did we not overflow our bounds? Are we below our max index? All right, so if our new index 1 is within our range still, well then we can actually grab that new pair. We have a new pair with this new index 1 and the old index 2. So we just advance one index at a time. All right, so you can think of this as grabbing, well, I wish we had a good example here. Yeah, so if we have this index and this index, those are the two smallest indices. Those are the two smallest values of both of those arrays. Next, we'll move to grab the second smallest value from the first array, but we'll keep the smallest value from the second array. That should give us a small value. But we'll also want to keep the first value, the smallest value of the first array, while we move to the second value of the second array. So we'll just move one at a time, and we're kind of moving, it's sort of like, I don't know, you take one step forward with your left foot, but you keep your right foot back, and then you switch and you take one step forward with your right foot, but you keep your left foot back. So you kind of go one at a time. All right. We only have 12 minutes here, so I got to do this fast. So we've advanced our next index for new index 1. We know that we're still within the range. So at this point, we can create a new pair. So let's see, we'll have a new value for this, and that's going to be nums at 1 for this new index 1. Plus nums 2 at the old index 2. So new element. Maybe I should call this new pair. Well, I'll call it new element. So our new element, again, we're going to have the sum first, so this new val. And our pair for this value is the new index 1 and the old index 2. And now we can add this element to our heap. So heap q.heap push. We'll take the heap first, and then we push our new element. All right, so that's on the left-hand side, or the nums 1 side. Next, we have to do the same thing for nums 2. So I'm just going to copy this whole thing. So we do the same thing for nums 2. So nums index 2, the new I2 is the old I2 plus 1. If the new I2 is less than the max index for 2, the new value will be the old I1 value plus the new I2 value. All right, and add this new element. All right, we push that on the heap. Now again, when we push these into the heap, it's going to keep these sorted so that the smallest elements remain at the top. That's going to be our key to helping us out here. Now one problem we might run into. So we grab this first element, then we grab the second element. We move to the second, but we keep this first. Let's move to the second. Do we ever run into a case where we have the same? We do. So let's say we grab this first element and this first element, then we grab this second element, but we keep this first element. Next, we grab this second element, but if we keep this first element in our next loop through, we'll end up basically having duplicates. So if we stepped into this 7 and 4 from going, I guess, from 7 and 2 to 7 and 4, we could go from 4 and 1 to 4 and 7. We end up with 7 and 4 again, which means we have duplicates. So we actually have to keep track of whether or not we've already seen these elements. So we'll keep track of our visited. This is taken from like graph traversal. So we'll have a set of visited elements. All right, so we actually need to do that here. We have our new element, but only if the new element is not in visited. Then we can add it to our heap. And then we also need to add it to visited. All right, so we need the same thing for both of these. All right, this is starting to look pretty good. Oh, but I missed. Our first pair is also supposed to be invisited here. All right, so that's just 0 and 0. All right, so while the count is less than k, I think this should do it. I'm a little bit nervous about this, but let's give it a shot. Index out of range. So what would happen here? This index out of range means we're trying to pop a heap that is empty. So let's just do a check while we have a heap and the count is less than k. All right, that should handle that. Oh, and we don't pass. Aha, because I am doing the wrong thing. It looks like I'm putting my indices into my result when I should be putting the values at those indices. All right, so let's try that. Nums1 at index 1 and nums2 at index 2. All right, give it a shot. Down to 5 minutes before deadline. Oh, and it's passing. Oh, fingers crossed. Let's see if we can pass all the tests. And we pass down to the wire. All right, we don't do great. We only beat 34% for runtime and 45% for memory. That's decent for memory, but not great on our runtime. Now, there are definitely things we could be doing in here to clean this up. I have a lot of these sort of helper variables, this new val, new element. We don't need to have separate variables for that. We could just do the comparison right here. So we could do some cleanup on this to make it a little bit faster. I am curious. Let's just jump in here and see how some of these these other groups do it. They're also using a heap. Does everybody use heaps? Yep, it looks like everybody's using heaps. So there are variations on the same solution. This one is just a more compact version of what we're doing. Let's see what the fastest one does. Yep. Oh, and they even have the same check here. So yeah, this is pretty much the same. Looks like they're not using a count though, they're just using the length of the pairs. I'm surprised that's faster, but hey, who knows? And they have just very compact version of what we're doing here. They're checking to make sure that they're within the range, they do the add, and then they update. Yeah, so very similar to what we're doing. All right, well, that is it for me. This was a rushed one. I apologize for that, but we had a deadline. So hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.